Hello, students. How are you? Yes, I hope you will be fine. This is Zaki Khan, and I am your mathematics teacher. Today, I will teach you differentiation for class 12. Okay. Uh, uh, Today, I have teach the previous year's questions. That is ICSE, CBSE both. Okay. Now, let us start. The question number one is under root 1 minus cos x upon under root 1 plus cos x. Okay. Okay. This question are arising in 2008. In 2008. Okay, students. Now that is, we know that 1 minus cos x is equal to 2 sine square x by 2. Similarly, 1 plus cos x, that is also equal to 2 cos square x by 2. Okay, y is equal to, now that is 2 sine square x by 2, 2 cos square x by 2, that is tan x square x by 2. Okay, tan square x by 2. Now let y is equal to tan square x by 2 to the under root. Okay, now y is equal to tan x by 2. We have removed to under root, that is tan x by 2. Okay, let us start the differentiation. Now dy by dx is equal to d by dx tan x by 2. Okay, now the differentiation of tan x by 2 is, tan x by 2 differentiation is sen sec square x by 2 d by dx x by 2. Okay, first time we have differentiate tan x by 2, that is tan square sec square x by 2. The differentiation of tan x is equal to sec square x. Okay, so tan x by 2 differentiation is sec square x by 2 d by dx x by 2. Okay, now sec square x by 2, the differentiation of x by 2 is 1 upon 2. Okay, concept clear? Okay, uh, now the next step is dy by dx is equal to sec square x by 2 into 1 upon 2. Okay, note down. Okay, students, this is the next question. That is sin y is equal to x times sin a plus y. Then show that dy by dx sin square a plus y upon sin a. Okay, this is the form of the numerator upon denominator. We have solving this question. Now solve to this question. Sin y is equal to x times sin a plus y. Okay, x is equal to sin y upon sin times a plus y. Okay, now firstly we have write the sin y and second times sin a plus y in denominator. Okay, this is the numerator and this is the denominator. We have using the identity numerator upon denominator. Okay, using the formula, we have using the formula that is using the formula from this side, differentiation numerator upon denominator, that is denominator differentiate into numerator minus numerator differentiate into denominator upon to the whole square of the denominator. Okay, this is the denominator. Now this is x. Now dx upon dy is equal to denominator, that is sine a plus y d by dy, that is the times of sine y na, in terms of sine y, that is the d by dy. Now sine y minus numerator is sine y, and the differentiate, that is d by dy, that is denominator is sine a plus y, denominator is sine a plus y upon denominator to the whole square, sine a plus y, that is sine square a plus y. Okay, we are solving the first step, that is sine a plus y, the differentiation of sine y, that is cos y minus sine y as it is, the differentiation of sine a plus y, that is cos a plus y. Okay, now this is the sine square a plus y. Okay, this is the if we have let a plus y is a and y, that is b, that is a plus y a and y is b, that is this is the formula of sine a minus b, that is sine a cos b minus cos b sine a. Okay, so cos b sine a, that is sine a cos b minus cos a sine b. This is the formula of sine a plus b, that is a plus y minus y upon sine square a plus y. Okay, now this is the sine a upon sine square a plus y. Okay, this is the dx by dy. Now the showing that is dy by dx, the showing that is dy by dx, but this is the formula of, this is the solving is dx by dy. Now the final proving is dy by dx, then the answer is reciprocal, the sine square a plus y upon sine a. Okay, then prove that, hence prove that. Any question regarding this question, uh, please comment in comment box, note down. The next question is differentiate under root tan under root x with respect to x. Firstly, we have write this question, let y is equal to tan under root x to the whole under root. Okay, now differentiate dy by dx is equal to d by dx tan under root x to the whole power 1 by 2. Okay, we have differentiate this question. Now this 1 upon 2 tan under root x to the power 1 by 2 minus 1 d by dx tan under root x. Okay, firstly we have solved this under root. To remove this under root, now this is the power of 1 by 2, we have write 1 by 2 and tan under root x, that is tan under root x and 1 minus to the power, that is 1 upon 2 minus 1. Okay, again we have differentiate d by dx tan under root x. Okay, this is the rule. Now the 1 upon 2, that is tan under root x to the whole power 1 by 2 into d by dx, that under root x, that, and that is sec square under root x. Again we have differentiate d by dx under root x. Okay, the differentiation of tan under root x, that is tan under root x is sec square x. Okay, and the differentiation of under root x, that is d by dx into under root x. Okay, 1 upon 2, this tan under root x minus 1 by 2 is the negative power. We have to reciprocal this question, that is we have to transfer tan under root x in denominator, that is the power 1 by 2 into sec square under root x, and the differentiation of under root s x is 1 upon 2 to the power minus 1 by 2. Okay, that is 1 upon 2 and 1 upon 2, that is 1 upon 4 tan under root x to the power of whole under root into sec square under root x into 1 upon under root x, because this is the power of x is minus 1 by 2, this is the power of minus 1 by 2 is negative, we have transferred this x to the power minus 1 by 2 to denominator, that is the power is positive. Okay, this is the final answer. Okay, note down. Solve this question now. That is dy by dx is equal to dy by dx tan x plus y. Okay, this is also dy by dx. Now solve this question, dy by dx. Now this is the d by dx, sorry. Tan x plus y, the differentiation of tan x plus y, that is sec square x plus y d by dx x plus y. Okay, the next step is sec square x plus y, the differentiation of d by dx, that is differentiation of x is 1 plus the differentiation of y is dy by dx. Okay, now the value of dy by dx is uh, this dy by dx is transfer in LHS, that is this is the dy by dx. Okay, uh, this is the multiplication of this. Okay, now dy by dx is equal to the multiplication of sec square x plus y in 1 times, that is sec square x plus y, and again this is multiplication of this plus sec square x plus y into dy by dx. Now this sec square x plus y dy by dx are transfer in LHS, it is dy by dx minus sec square x plus y dy by dx is equal to sec square x plus y. We have common to dy by dx is 1 minus sec square x plus y is equal to sec square x plus y. Okay, now the dy by dx is equal to sec square x plus y, sec square x plus y, and this 1 minus sec square x plus y goes to denominator, 1 minus sec square x plus y goes to denominator. This is the final answer in your question. Okay, any doubt regarding this please comment in comment box. Okay, this is the most important questions of the differentiations, note down. Now the next question is uh, y is equal to sine inverse bracket open x times under root 1 minus x minus under root x times 1 minus x to the whole under root, and the bracket is closed. Firstly, we have to solve this question. Now let us consider x is equal to sine a and under root x is equal to sine b. You know, reason for this, because we have to generate the formula of trigonometric terms. Okay, now we have to solve this question to understand what I am saying. That now let x is equal to sine a and under root x is equal to sine b. Okay, now y is equal to sine inverse, that is this is the sine a, this is the sine a, and the under root 1 minus x square, 1 minus under root to the whole square. We have to write this 1 minus x square in terms of 1 minus under root x to the whole square. Reason behind this, we have to generate the formula of sine a sine b. Okay, now this is the under root x, that is sine b, and 1 minus x square, that is sine square a. Now y is equal to sine inverse sine a 1 minus sine square b, 1 minus sine square b, because the under root x is sine b, that is the formula is this is the we have to write 1 minus sine square b minus sine b under root 1 minus sine square a. Okay, we have to write this question again. Now the sine inverse sine a, this is the formula 1 minus sine square b, that is cos square b, and the under root is that is cos b. Okay, to remove the under root, minus sine b times 1 minus sine square a, that is the cos square a, that is cos a. Okay, this is sine a cos b minus cos a sine b, that is this is the formula of sine a minus b. This is the formula of sine a minus b. Okay, now we have to remove sine inverse into sine, that is remaining part is y is equal to a minus b. We have to put the value of a for this equation. Now the y is equal to sine inverse x minus b is equal to sine inverse under root x. Now we have to differentiate, that is dy by dx is equal to the differentiation of sine inverse x is 1 minus x square to the whole under root, when the differentiation of sine inverse x is 1 minus under root x to the whole square का under root into the differentiation of under root x is dy by dx under root x. Okay, now the 1 minus x square, this 1 minus under root whole to the x square is removing this, that is 1 minus x, 1 upon 1 minus x to the whole under root into the differentiation of is 2 under root x. Okay, now this is the final answer. 1 upon under root 1 minus x square minus 1 upon under root 1 minus x into 1 upon 2 under root x. The differentiation of sine inverse under root x is 1 upon under root to the whole under root 1 minus x. इस x का अंडर रूट करेंगे ना, तो इसको जो होल स्क्वायर हम लगा देंगे. ठीक है, नोट डाउन.